Hi everyone, this is Sai Vignan Malayala. I will be going through a series of lectures on NLP. NLP means Natural Language Processing. NLP being a very topic nowadays has a lot of importance in the real world and a lot of demand too in the market. It's a branch of data science that enables machines to deal with human language in a systematic process by analyzing, understanding and deriving information from the text data. It is said that only 21% of the available data is in structured format. Data is getting generated always. The data is getting generated as we speak, as we chat, as we tweet, as we post, as we blog, as we write articles, as we write reviews, as we write records. And all this data is in the form of highly unstructured format. And it's a high dimension data. It will be useful to us or to anyone only if it's analyzed in a proper system. To do that, we require NLP. By that, we could generate very good actionable insights. So, before going ahead, let us discuss some of the applications of NLP in the real world. So, here are some. Information extraction. It's a concept where we could extract text or information from large bodies of text like articles or documents. The second one is topic segmentation. So here we could use this technique where we could understand the users, what they're talking on or what they're discussing on or what they're speaking on from the text bodies they're generating. And the third is machine translation. I could say the best example for machine translation is Google Translate. And the fourth is automatic summarization. Automatic summarization is a technique by which you could extract the summaries from the articles or documents that have been created without human intervention. And the next one is speech recognition. The best examples I could say for these are Apple Siri, Microsoft Cortana, Alexa, the similar ones. And the next is document classification, as it's understood automatically. And the chatbots. So chatbots are a lot prevalent now. It was a situation where every company wants a website some time ago. Now every company or every website wants a chat assistant now. It's so prevalent in current world. Sentimental analysis. I think this is the first application people learn in NLP, and I think most of you already know what it is. And spell checking, keyword search, semantic search, and ad matching. So advertisement matching or ad matching is a way of recommendation system where you're trying to match the right ads with the users. So there are a lot more applications in NLP. Let's also discuss popular libraries which we use in NLP. So here are the some which I mentioned here. NLTK, NLTK. NLTK means Natural Language Toolkit. It is an essential library for learners especially, and it supports various tasks like classification, stemming, tagging, parsing, semantic reasoning, and tokenization in Python. It's one of the main tools in Python for NLP, I could say, and good for learners to start with. Text blob. So text blob is a must library for developers. I could say it supports basic tasks like sentiment analysis and pivot tagging and the similar ones as I said in NLTK. And the next is core NLP. So it's basically Stanford core NLP. It's a library that is developed in Java. It is including wrappers in Python 2 now. It's really fast and works very well in product development environments too. Its components now can be integrated with NLTK also. And GenSim. GenSim is a wonderful library. It's mostly used library, and it is a library developed in Python, and that specializes the identification of semantic similarity between two documents or between two texts. You know, and it's a toolkit built through vector space modeling and topic modeling toolkits. It can handle large text corpora. We did not worry of the text corpora it can handle. It can handle good size data, and it's efficient in data streaming and incremental algorithms. You could update the models too with this libraries. And one of the main things is about this libraries. It's loud. Actually, it is loud for two things. One is memory usage optimization and processing speed. It's good with these things. And Spacey. Uh, Spacey is one of the favorite libraries for many developers like me. So it has broad range of analysis and great language coverage. It's very efficient too. And scikit-learn, I think many of you who already know machine learning might have heard of scikit-learn. So it's a learning library too, and it's an intermix library for NLP and many wide range of ML algorithms. However, this library doesn't support neural networks for text processing. It's only confined to ML. And the last I could say is pattern or pattern 3. It's a lightweight and good library, and it's another gem library, and it supports pivot tagging, sentiment analysis, vector space modeling, SVM, clustering, n-gram search, word nets, and it is only confined to certain tasks. It can't do all the tasks, and it's essentially a web miner. Okay, so that's libraries we are confining to for now with NLP, and these are actually sufficient for our learning. We would start with NLTK, Natural Language Toolkit, and I would go through some of the applications or some of the ways we could solve some of the problems in NLP using NLTK now. So there are two components of NLP, NLU and NLG. NLU means Natural Language Understanding. So it's basically understanding the data or the unstructured text data based on grammar, the context in which it is said. So it's basically converting unstructured text data to a structured form. Like suppose, for example, in chatbots, the text or the chat unstructured data is converted into structured format in the form of intent and entities. And the second component of NLP is NLG, that is natural language generation. So it's a process where we try to generate text based on the structured data. So NLP covers these two tasks. They are NLG and NLU are subcomponents of NLP. So going ahead, I will be covering the topic of text processing. Text processing is a first basic step we need to do in any NLP task. So these are the following topics I will be covering under text processing. So it will be an overview of NLTK Corpora. NLTK, as you know, is an important library in NLP for the learners, and it has various corpora abundantly available which we could use and learn things. I would go through it, and after that we will do analyzing of frequency distribution of words of a sample corpora. After that we will go through text pre-processing process, which allows or which considers the following things like noise removal, tokenization, stemming, and lemmatization. After this, we will go a little more ahead into advanced topics of NLP, which I'll discuss in the next lectures too. So I am having Python 3 in my system installed, by which I am running my things, and I am setting up a Jupyter notebook as I am showing in the screen, so to demonstrate my workings. Now I want to download NLTK library. So the command is very simple. It's just pip3 install NLTK with exclamation mark in Jupyter. So this installs my NLTK library. It says successfully installed, and NLTK has a dependency on 5 other libraries: click, joblib, regex, and tqdm. So all are installed and it is successful. Now if I do import NLTK, it should work, and it has worked. Now I want to download some corpora or predefined corpora of NLTK. If I do NLTK.download, it will ask me some suggestions on what to download. So the sample will be like this. It will ask me all these identifiers and what to download. I would just say I want to download everything. So I write nltk.download all. So once I run this command, it will take some time and it will download all the packages with respect to NLTK. And after this, it says successful or true. So my NLTK Corpora is all set and I have downloaded everything to showcase the demo. NLTK Corpora helps us to get some already existing labeled, categorized and tagged data. NLTK library also has some built-in methods to facilitate easy access to initialize and use these corpora for our use cases. So let me give some examples of NLTK corpora like Gutenberg corpus. So Gutenberg corpus, it's a corpus of 18 books by renowned authors including Shakespeare. So it has around 2 million words as it is said. So Gutenberg corpus, you could use it of 18 books. And there is something like Brown corpus which is mostly used. So Brown corpus is a text of 15 different genres and it has around 1.15 million words. So it's all tagged, categorized. It includes various genres like fiction, romance, and many more. Um, so it's like 1.15 million words. It's around 2 million words. And there is something called Router's corpus. So Router's corpus, it's a data set which is categorized and it contains documents of around 10,788 news documents. 10,788 news documents and it has around 1.3 million words. So these documents are also classified into 90 topics already classified, and it's provided to us in two sets. One is training and test. And the next corpus, there are a lot of corpuses or corpora, but I am just giving you a brief of some of the important and most used ones. Having an idea on this corpora helps us to build use cases easier and faster without gathering the data again or redoing the work again. So the fourth one is NPS chat corpus. So this is a corpus which is like full of chats of almost like collection of 10,000 chats over IM. So it's also POS tagged, it's and dialog act tagged. According to dialog also it is tagged. So just have a view. I could also give a document of other corpuses available for your references now. So see, this is the NLTK corpus list and there are a lot with the corpus name, compiler and contents. I could say these four are mostly used ones and help us for our working now. So how to use this corpora? Let me show that. Let's try with the Gutenberg corpus, which consists of 2 million words and it's a combination of 18 books by renowned authors. It also contains Bible and Shakespeare's books too. So from NLTK.corpus import Gutenberg and I run it. It's working. and Gutenberg dot file IDs. So now I can get all the list of it. So these are the different books or different texts available according to file IDs here. So you see this Bible, sorry, even Bible also is existing here. You can access this corpora in three different ways. One in the raw form, one is a word form, one is a sentence form. So if I just say the raw form, raw underscore text, or I'll just say I'll take Bible equal to Gutenberg dot raw of Bible. Sorry. So now I got the Bible loaded. So raw Bible of 0 to 100 characters. Okay, I got it as raw. So if I just say raw underscore Bible of 0 to 100 characters, it will show me top 100 characters of this book. So so this is a sample output. Second way, if I say uh, Gutenberg, let me get the words now. List of words of Bible equal to Gutenberg dot words of now I got the list underscore words underscore Bible. Let me take top 10 words 0 to 10. So it has come as a list. I hope everyone knows what are Python lists. So Python list of top 10 words. Okay, and let us take now the similar one by accessing sentences. List of sentences of Bible. Sends. Command is sends. So now again, let me take maybe top 3 sentences. So first sentence, second sentence, and third sentence. So this is the way how you could access the corpuses in 3 different ways: raw, words, and sentences. Okay, let's also check out the brown corpus from NLTK dot corpus import brown. So I'll just say brown dot categories. I will get an understanding of how many categories of brown are there. As you remember, I have already said that brown corpus is a combination of lot of genres. So brown corpus has lot of categories, and let's see what are them. See, there are different categories of genres of books: adventure, novellas, letters, editorial, fiction, and all. So let me again see what are the file IDs for different texts I wanted. Brown dot file IDs. You can only access them using file IDs, right? So that's why I'll give file IDs and I'll give it categories here. Let me say I want category called humor. So these are the different file IDs for the category humor. So this is how you could also extract them. You can give a lot of other lists too in this combination of category list. If I wanted to access certain category again, Okay, before that, I would again check out the root path for it. Brown dot root. You already know that corpuses are installed in your system, but you want to know where it is installed. So this is the command. So this is the path where I have installed this brown corpus. So next thing I would be discussing is the frequency distribution. So it's an often used task where we need to know the frequency distribution of words in an article or a document. For any given task in NLP, to analyze the text or understand the text, you need to do some frequency distribution somewhere or other. So I'll be covering two types of frequency distribution. One is a generic one, and the other would be conditional. Conditional frequency distribution. And so I would be covering the examples like the top n words in an article, or the frequency of a particular word. Suppose the word the has appeared 10 times, book has appeared 100 times in an article, and third is plotting. So NLTK library has an available library available syntaxes for it. Okay, let's start with it. So I'll just say from NLTK import frequency distribution. I think I've already written it. So let me take a sample string for our explanation. Can you? So let me take a tongue twister. I was just thinking. Can you can as the canner can a can. So this is a sample tongue twister. Can you can as the canner can. So let me find the frequency distribution of the string. FD is equal to frequency dist. So let me convert the string to a list. Okay, so this first line converts this sample string into a list of words split by space by default, and I'm converting this FD or frequency distribution as list of sample strings. So I'll just say print list and print FD dot most common. So most common of 10 words, or maybe I'll give 3 because it's a small sentence. So can you can as a canner can. So the most common words in this string are can has appeared 5 times, capital C can has appeared 1 time, U has appeared 1 time. Okay, so this is the way you could get the frequency distribution. Let me check out this in brown corpus. Okay, as we already know, brown corpus is a categorical corpus. It has a lot of genres included. So from NLTK dot corpus import brown. So let me take sample corpus, maybe humor one. Brown dot words of categories equal to humor. So humor text, let a sample 0 to 5 words. I'll just see. So these are the top 5 words. So I will order it. Now I'll just check the length of this text. So it has completely 21,695 words. Okay. So let us implement the frequency distribution here. It's already a split data. So now fd dot, fd human dot, let me take most common of top 10 words. Sorry, it's a spell mistake. Yeah, so comma has appeared 1331 times, the has 930. So I think most of these are the stop words, but anyways, to just get the frequency distribution is sufficient for now. Okay, let us remove the stop words then from, okay, from NLTK dot corpus import stop words. So stop words equal to words of English. Okay, so let me check the length of the stop words according to NLTK, which was designed below. So it's 179 only. Let me just check it out. The words. Okay. So it seems these are the words according to NLTK are, the stop words. Let me add some more. Stop words dot append. I'll add or I'll extend it. Some words like some things like this, question mark, comma, and exclamations also, and full stop. Let me see something else. Okay, this also. And this also. Okay, so now just check the length of stop words. So it's 186, is increased. Now let me do one thing. I already have a humor corpus, right? So humor text, right? So humor text equal to, it's all words, right? Now word for word, I'm writing a comprehension, list comprehension, word in humor text. Clean. Let me name it as clean. If word not in stop words. Okay, it's done. Let me just check the length of this. It has decreased. Now it is 10,457. Previously it was 21,695, and if I just remove the stop words, it has gone to 10,000. I think it's almost half. Fine. Now I think I can get a good frequency distribution. I'll do the same. Humor text clean, right? And let me get the most common. So I think there are still more stop words like the and all. Okay, let me do one thing. I'll just do it lower. and also add these brackets and all. Actually, you can cover all these things in regex also. I'm just trying to explain some things how ideally you have to do text processing. And you can cover all these things with regex also. Okay. It's gone to more or less. Now I can say I, the, he. So these are all the most frequently used words in the corpus. And if I just say, if I just wanted to also check the similar, similar thing, like if I want to check the have access. I hope everyone know what have access. So if I just say dot see have access, so these are the have access I got, and let me also check the similar. Maybe max. I'll show what is max. So most used word basically I. We already got it here. There's a different functionalities basically. And if I just want to check the frequency of the word called with the I'll do frequency of the, so it says the frequency is this much. So it's a calculated frequency, and how do you get it? This value is count of the word by total number of words, length of words basically in corpus. And if I say, if I just want to get the count of the word and prove this is correct, I'll do something. F2 dot get the, it's 97 times, and the length already we know, we already seen just now, it is 10190. If I just say 97 by, so it's same, the value is same, so that's why it's frequency. And fine. So let's check out now conditional frequency distribution. So how do we do this now? So it's again the same input except the word change. So from NLTK import okay, it's imported. Now I'll give an example how what is the difference and how we could use conditional frequency distribution. Let me take some sample list for explaining this. It should be a tuple. Maybe I can just say category 1 comma, suppose category 1 is spam, and then again the category 2 is ham, and again category 1 is spam, suppose. And if I just say conditional frequency distribution is equal to of this sample list, and if I just see FT, so the frequency distribution of this category 1 is 2, and frequency distribution of category 2, that is ham, is 1. So it's a sample example I'm trying to give you here. Let us try to implement the same in a genre. We already know we have a brown corpus for genres. So from NLTK dot corpus import brown again. If I have missed, I'm just making it short. Let me create a list comprehension for this case. I will just say CFD conditional frequency distribution is conditional frequency distribution of. Let me take two things in my frequency distribution. One is the category and word, right? So if I say genre, genre and the word, suppose for genre in brown dot categories. Again, for what? For a word in brown dot words of again categories equal to let me give a list of genres again, right? So if I just say my list of genres, let me take some genres like what are the sample ones you've just seen, right? So adventure, hobbies and humor and fiction, 4 things. So let us take these 4 genres, and I've created the frequency distribution thing. And suppose I want to analyze on certain words. Maybe I'll add something like model words. That's equal to let's try to analyze the words like can, could, shall, should, and may, might. I'll understand what type of words they're using in these things, and will and okay. So these are my words I want to understand. So now I say CFD dot tabulate my I have to give a condition because the conditional frequency distribution, my condition is genres. List of genres, and the samples is model words. Yeah. So if I see this, what you could see in adventure genre, I have seen can has appeared 367 times. Fine, because I have given a genre here in the same thing. So it's taking time. Yeah. Now if I see, I have covered all the genres for the conditional frequency distribution for genre comma word in genre of all the categories for word in brown dot words of this genre, and the model words I'm trying to analyze is can, could, shall and all. And if I tabulate and the condition is this list and the model was on this, I could say the can has appeared 46 times in adventure and 151 times, of good in adventure, whereas hobbies it is only 58 times. So I think I could analyze can is a word which is more used in hobbies. Yeah, it seems right. And no, in humor, can is used very less. And if I say shell is almost like very less used compared to any other. And would, would, and will, and can are the most frequently used words in hobbies. And hobbies cover can and will a lot. So there are different analysis you can get out and understand what texts are using and what they're not using and what kind of words are conditionally formatted with. Let me now show you a use case. I'll do something like I'll try to understand the names, no, the name differences between male names and female names. Um, okay, fine. Let me do one thing. I'll create a hypothesis and try to work on it. Hypothesis is uh, more female names uh, end with a or sorry I or I'm just guessing this because in India I have seen how female names end and how male names end. So I'm just trying to guess like the hypothesis like more female names end with the character I or a, compared to male names. Okay, because I have seen in India like like most of the names, the female names like female names like suppose Kirti, Kriti, end with I, Rupi end with I, Puji end with I, know, or words like uh, Manasa end with A, or Veni end with I, Vani end with I, Spandana A, Shri I, Shri I, Riya A, Neha A, no, Karina A, Katrina A, Aishwarya A. So I see most of the words in India, the female names end with I or A. So I'm just making a hypothesis. We'll solve the hypothesis and just confirm whether the hypothesis how it behaves, like whether it comes true or no. And male names, I don't see any ending with A. I don't feel like any man having a name called Aishwarya or something. It's like more of a girl name. So let me check out. Anyway, the corpus is mostly in the case where it's designed generically. It can be Indian or foreign too. The corpus. So NLTK has a corpus called names. Names. Okay. So names dot file IDs. If I do, okay, I think I spelling mistake again. So it has two texts, male and female. Fine. So let me consider these two. I don't know how many words are there in this text. Let me check that out also. Like males equal to names dot words of male dot text. So I'll use the print and same thing like in the female ones. So there are completely almost like 3000 male names and 5000 female names in this corpus. Fine. I'll do conditional frequency distribution and find my hypothesis working. Like list of names I'll create, as you know. If So it's like list of I'm again creating a list comprehension type of thing. So I just create two categories, male comma, so name. So I'll just take the last character. I don't want full data, right? Only the last. They end with the last character -1. For name in email names. Okay, and I'll add this to the one more. So it's like female for name in female names. Okay. Okay. There seems like a syntax thing. Okay, it's a tuple one. We are getting is two words key, two keys here. Yeah. So if I just check the length of all the names, it should be added, right? It's like 7944. It seems proper. Now I'll do conditional frequency distribution, CFD equal to conditional of list of names, and CFD dot, I'll do plot directly. Okay, so you need to install MATLAB plot for this. Quickly install matplotlib. So it has installed matplotlib, and now I'll just again run it. So it has run, and it is saying that word A, so there are two, male and female, and orange seems female and blue is male. So the character A is there in 1750 female names, and almost like null in male names. And I said second one is I. So I has appeared 260 or 270, 300 times almost in female names, ending with female names, and in it is like maybe 100 or 50 in male names. So my hypothesis is true, and most of the female names end with I and A compared to the male names. So this is how I could analyze the names, and using conditional frequency distribution. So the next topic we'll go on to discuss is tokenization. So there are two types of tokenizations I will discuss. One is sentence tokenization and the other is word tokenization. So as we know, 90% of the NLP tasks cover massaging the text data before we give it to the algorithms, right? So tokenization can be considered as a first step for this. Let's start with it. I'll just start with sentence tokenizer first. So from NLTK.tokenize import sentence tokenize, and NLTK.corpus import Gutenberg, and Gutenberg.file IDs. I'm just trying to get the Gutenberg data. So let me take a sample one, Austin Emma. Okay. So if I say I'll take the raw data, so raw data equal to Gutenberg.raw as we discussed in the starting of, I'll just copy this. And let me take some characters. So raw data maybe from 50th character to 1000 characters. Okay, so this is the data from 50th character to 1000th character of this. Maybe I'll consider, a little less, 950 or something. Okay, so let me perform the sentence tokenization on this data. So if I say MR data equal to raw data of 50th character to 948 as we have seen, and let me say sentence tokenize of MR data, send tokens equal to sentence tokenize. Yeah, so I can see that I got some sentences for these characters. So till here is the first sentence, and then the next sentence, and the third sentence. So I got 3 sentences, I hope so. No, 6 sentences. 1, 2, 3, 4, 5 and 6. So I got 6 sentences in these characters. And okay, you might be thinking maybe this sentence tokenizer is just splitting the data or the text by full stop. In that case, there's a full stop here. After Mr. it has a full stop. So MR is abbreviation, right? So even in that case, it has to perform, the sentencing, right? It hasn't performed. That means it is not splitting this text data by full stop. Suppose I say, MR data dot split by full stop. So I got, split by Mr. also. It hasn't happened here. So it's not splitting the data by full stop, but it actually is sentence tokenizing the text based on how it has formed. Okay, so that is called sentence tokenization. And the next would be word tokenization. It's simple and straightforward, just converting all the text data into the words. It will take even the full stops and all also as a different word itself. Okay, so let me import. The import will be from tokenizers. You have to import word tokenize. Okay, word tokenize. And if I say MR data is already there, so let me check MR data. Okay, so word tokens equal to word tokenize of MR data and word tokens and length of word tokens. Yeah, so I got 177 words, and so these are the words. You see the comma, the full stops are also taken as a different word according to the word tokens. It is not again splitting by space or something. Okay, it is trying to word tokenize according to its actual thing. It will also tokenize the full stops and all separately, right? So this is word tokenization. They are the basic simple step. There is nothing extraordinary in this tokenization, but knowing the concept is actually required for all the data processing techniques. Yeah. So the next topic is text or object standardization. It's an important technique in NLP, but I see a lot of NLP developers ignoring it. It has its own importance. Basically, as we see in our daily chats or articles, people write different spellings, which we might understand. Just like in this raw chat, I have just given an example. It's an amazing video. I like it and want to DM the expert. He seems awesome. So here I used words like AMZG, which means amazing, AWSM, which means awesome, DM, direct message, XPRT, expert. The spellings are different, but the meaning is same. So we as NLP developers should handle these situations and standardize them into certain format. The reason why many NLP developers ignore this task is because either they don't know about this, or they feel it's a lot manual work. Yeah, it has a lot of manual intervention where you need to find the commonly used words and convert to a specific format, but it is required in the real time scenario for enhanced results in the algorithm. Okay, so let me take this to raw chat, a sample chat I have written, and the lookup dictionary for the small dictionary I'm maintaining to show you an example. So I'll just write a function. So I'm trying to write a function called standardized text, and I'm passing an input text and replacing all the used words to a certain right format. And I say this, and once I written the clean chat, it has converted my raw chat to a cleaned chat. It is an amazing video. I like it and want to direct message the expert. He seems awesome. So this technique, although is very small, has a minimal intervention in a lot of things, has its own importance. Please don't ignore and try to follow as much.